Okay, so dear colleagues and students, thank you very much for joining us. Can you hear me?
Yes, Professor. Yes, please continue.
Okay, thank you. So we have some people who are sitting here. They can. Okay, and partially we have people who are sitting online. So so today's workshop is devoted to the technology and innovations that are related to SDG of United Nations. And so let us first allow to students who came offline to present their posters. So the first will be Farhad. He's from Satpayev University, and let us share his presentation. Okay, so you can see it.
Good day, everyone. Can you see my screen?
Yes, we can see.
Can I start? Can I start? So,
yes, please start.
Yeah. Hello, my name is Farhad Muhangaliyev. I'm the second year master student at Satpayev University, and my topic is smartphone security based on context-aware user profiling, or an intelligent smartphone protection system based on user's context. So my introduction is today smartphones store a huge amount of sensitive information. Losing the device or having it misused can lead to data leaks. Financial losses, and even identity theft. So traditional protection methods like passwords or biometrics are not always reliable, and especially if the device is already unlocked. So there is one solution that I prepare. I propose a context-aware access control system that evaluates various parameters during each login attempt, such as the user's location, like here. the user location, time of access, internet connection status, device type, and also the behavioral patterns. The system analyzes these signals using a machine learning model. If the behavior is suspicious, for example, logging at night or from a new location, it activates an additional security layer, such as a pin code request. I developed a mobile app prototype to collect real-time contextual data. The collected data is processed using machine learning algorithms such as random forest, isolation forest, and decision tree. In particular, random forest, which showed the best performance. I collected more than 10,000 login attempts, including normal and simulated attack scenarios. The model achieved a F1 score of 91% and accuracy of 92%, as you see in the middle, right here. Random forest is a first, and also you can see accuracy chart in the bottom of it. So the results in normal situations, the user gets instant access. When anomalies are detected, such as unusual location or time, the system triggers pin code verification. In real-time testing, the system behaved correctly in 97% of cases, and false positives were minimal. So this project supports in following SDG 9, industry, innovation and infrastructure by developing intelligent digital protection systems, and also SDG 16, peace, justice, and strong institutions. It contributes to digital security, protects user privacy, and strengthens trust in mobile technologies. So the conclusion is, my bad. Wait. The system is a step forward, smarter and more adaptive mobile security. In the future, I plan to enhance behavioral tracking, reduce energy consumption, and implement secure data storage mechanisms. Thank you for your attention. That's all.
Okay, thank you very much. May I have one question?
Yeah, sure.
Okay, so how you evaluate your this? I mean, how you did the real world experiments? Did you perform real world experiments or some simulations? I see some here chart here.
I collected over 10,000 login attempts through my phone, and I trained my model, several models, as random forest, isolation forest, and decision tree. I did an analysis, so the best choice was random forest. So I just created some models on my data set, which contains only 10,000 login attempts.
Okay, so how if you, I mean, the user enter invalid pin or invalid data, then what is the I mean the success and failure in that case, success failure rate?
Can you repeat, please?
Actually, I cannot see this graph. If you can increase the can you increase the size of this graph? I cannot see exactly what is on the x-axis, what is on the y-axis. This graph, can you increase the size of this graph? Result graph.
This one?
Yeah, okay. So this is accuracy chart. The decision tree, isolation forest, okay, random forest. Accuracy. Okay. So how you calculate this accuracy? This is my question.
I didn't understand. Can you repeat it, please?
I mean, how you calculated this accuracy of different machine learning algorithms?
Может, кто-нибудь перевести, пожалуйста? Я не понимаю немного.
Can you hear me?
Yeah, I can hear, but I
Okay.
don't understand. My, you know, my English is not so very good.
No, your English is very good. Just let me try to explain again. So you, I'm referring to figure number 2, accuracy chart, right? Accuracy chart, figure number 2. So how you get this chart?
Yeah, so they're really, as I understood, how did you get this chart?
What
is the accuracy? Yes, because it's
as I told, I trained my three models by my data sets, and this is what I get. This is accuracy what I get by the codes that I wrote.
Maybe what is the accuracy? So how did you measure it? How did you measure the accuracy? What is the function behind it?
It's just simple code on Python.
Will you explain? So now it's getting
I don't really remember what I wrote in the codes. What library I used, but I remember.
Maybe you remember how it's called, like so there's boosting or bootstrapping and so forth.
No.
Okay, that's fine for me.
It's just a basic machine learning. I just use Python to recreate these models.
Okay. So actually, what my question was that you calculate this accuracy. How you calculate it? You should know the background formula, right? That how you calculated, like maybe the number of success divided by number of failure, a number of failure divided by number of success multiplied by 100. Something like that.
Yeah. Now I understand. Graph of success, success attempts and etc. I don't have it because I did only the result as accuracy and F1 score, because code give me only that. I didn't wrote that. I didn't have that.
No, my comment is that just you should know the formula, mathematical.
Yeah, I know the formula. Yeah, I know.
Behind this, what is accuracy, what is recall, what is F1, because you are engineering students, so you should know the not only just code, but you should know
I know the accuracy formula.
Okay, thank you very much.
I think this is we need to. Как это пообъяснить на английском, боже? Да там вопрос задали, я не могу объяснить на английском нормально.
I think that Professor Ilyas, maybe after the session I can connect you and Farhat, and maybe more questions you can ask privately.
Yes. Because if we have some formula for accuracy, mathematical formula, like true positive and false negative, something like that. And based on that, you calculate the accuracy. Similarly, F1, recall. So just my comment that the students, because your students, this is your good work. So I mean, the mathematical modeling or mathematical development is a key for engineering students. So not just coding. So this is my just comment that for in the future you also include some mathematical formulas you use in your research. So, thank you.
Okay, I get it. Thank you.
Okay, thank you very much. Thank you for your presentation. So the next presenter is Madhi. So everything is yeah. They have.
Hello, everyone. My name is Mati Husenov. I'm a second-year master's student from Kazakh British Technical University. And my topic for today is hybrid AI-based air pollution forecasting for sustainable cities and communities. So to start, I think the majority of us, if not all of us, are familiar with the problem of air pollution, how badly it impacts all of us, So, for example, according to the World Health Organization, 99% of the whole world lives in areas where the amount of air pollution exceeds the limits. For example, to give you an instance, just in 2019, approximately 4.2 million of people have died because of diseases that were caused by air pollution. So it means that there's a growing need for tools that predict air pollution to mitigate the environmental impacts they cause. So my work focuses on the development of an AI-driven hybrid model that forecasts air pollution that allows for preventive actions from the local governments and from the citizens themselves as well. The proposed model is deployed within a modular architecture that is suitable for integration into smart system platforms. It can be embedded into mobile applications, municipal dashboards, which makes it flexible component in the broader smart city ecosystem. So when it comes to methodology, it basically embeds Aramax and LSTM models. Aramax is an autoregressive integrated moving average with exogenous variables, which is used to capture linear dependencies, linear trends basically. And LSTM is a long short-term memory, which is used to learn on the residuals from the Aramax model. And in the end, we combine the results of the trained models to get the better forecasting predictions. So for the data, I've used the historical and meteorological data for Almaty for the past 5 years, starting from 2020 until 2025, which includes wind speed, temperature, the humidity levels, the precipitation levels, etc. And for air quality, I mean, I've also used historical air quality data, which includes the CO levels, SO2 levels, NO levels, ozone levels, and PM 2.5, which is the particulate matter that I am predicting in this specific model. So here you can see the detailed graph for the model, which starts with the data collection. As I mentioned, air quality data and weather data. Continues with merging the data and pre-processing it, which involves removing null values, creating lag features. Then I split the data into testing and training sets. I train Aramax model to capture the linear trends and seasonality. And then I train the LSTM model. Getting the trained models, I combine them using a meta model, which is trained on weighing matter. Basically, it weighs the results from both models and results in a better prediction. Yeah, so in the end, we get the final prediction, final model, and to evaluate its accuracy, I calculate the RMSE and MAE, which are root mean squared error and mean absolute error, and then I compare the models. So here we can see the results. The evaluation metrics of standalone Aramax LSTM and the proposed hybrid Aramax LSTM models. So as you can see, the proposed model is significantly improved when it comes to the accuracy. Specifically, it improves, it outperforms Aramax model at around 32%, and standalone LSTM model at around 16%. So this confirms the hypothesis that the hybrid model outperforms standalone approaches. It is especially valuable in smart city contexts where sudden changes in air quality demand timely and reliable forecasts. And the improvement in air metrics is a crucial step toward proactive and air quality management. Talking about relation to SDG, this work supports SDG 11, which is Sustainable Cities and Communities, with a strong lean towards target 11.6, which is removing the environmental impact of cities. It allows basically cities to, through accurate predictions, to go from reactive approach to the proactive approach, basically giving local governments the needed time to mitigate the negative effects that can be caused by air pollution. It can be rerouting traffic, it can be adjusting industrial activity, it can be basically issuing health advisories to the citizens. And the proposed system can also be used to empower and engage citizens to also take actions. For example, as I mentioned before, the model can be used as a module in a mobile application, which citizens will have the access to. And by seeing the forecasts, they can minimize the exposure to air pollution. Again, it can be, they just can reduce their, minimize the time that they are being outside. They can use special equipment such as respiratory masks, etc. This is basically it. And I would also like to express my sincere gratitude to Professor Selek Jalova for her invaluable guidance and insightful discussions and the support throughout the research. Thank you for your attention.
Hello, Madi. Good presentation. Do you hear me? Hello.
Hello. Можно тут звук потише сделать? Там очень плохо слышно.
Тут
Can you hear?
escape, видите? И вот тут звук.
Yes, it just, the sound is very incomprehensible. Can you repeat again, please?
Turn off my fan. Okay, can you hear me now? Is okay?
I think.
Hello. Okay.
Yeah.
Just I have one short question. You created a hybrid model using Remax and LSTM. So how you combine these two outputs? Is it weighted output, something? How you combine the output of these two models? What is the hybrid?
The question is how I combine both models, right?
Yes.
So yeah, as I've mentioned before, I'm using a meta model to combine the predictions from Remax and LSTM. The meta model is used to weigh the outputs that are produced by both models, and by weighing the outputs from both models, the resulted meta model can produce the more optimized and refined forecast.
So meta model means that it is a weighted output. So how you select the weight?
Could you repeat again?
I mean it means that it is a weighted sum of two outputs, right? Weighted sum of two outputs. Model 1, model 2, and then you combine them as a weighted output, weighted sum of two outputs. So how you define the weight value?
How I find what exactly? I'm sorry.
Weight value. Weight. Can I write in the chat?
Sure.
Wait.
Well, the data is the outputs from both from Aramex and LSTM models are compared to the actual results, and based on that, the meta model weighs them on the accuracy.
So can you see my chat? I put my question here in the chat. Okay, so I put my question here.
So yeah, then it's basically again comparing the output from both models, compares it to the actual values, and gives it the weight. So based on how accurate are results from either of the model, it uses those to learn. If you're asking me how I specifically did it, it's done by the Python function. I used the Python library, and it's doing it under the, like I didn't specify it basically myself.
Mm-hmm. Okay, thank you very much.
Okay, thank you.
Hello, can you please open the mic? We cannot hear you. Rahim Ahmed, can you open the mic?
Can you hear me now? Am I audible?
Okay, now it's okay.
Okay. So I am Rahim Ahmed Ruba. I'm representing Alpha Arabi Kazakh National University, and I have my teammate. He studies here in Kazakh British Technical University. So we choose our title as urban noise mapping mobile devices, a citizen-powered approach to sustainable cities, which is included in SDG 11. Because in SDG 11, the goal of SDG 11 is to work with sustainable cities with pollutions, and this work especially goes to 11.6 section. So here what we did is we just proposed a model where we have a model architecture, and if we see this model architecture, we have this method, here with this method we take these specially there will be a mobile app. In this app, the citizen have the responsibility, maybe whenever they are passing by with some noisy places or it's too much noisy, they will record the noises as decibels, and it will then we use some mathematical equations here to maybe smoothen our results to show off, and it will show off something like this. These are like mock-up visualization. Here we can, for example, yeah, nonsense. So here we have this type of mock-up visualization. Here this type of heat map will show in this format, where they can see that this is too much noisy, and also government can also take actions according to it. So about our model, my friend, my teammate who will explain you about the model to you. Can you just yes, because
Okay. So we have the model architecture. In that, first we capture the sound of our surroundings, like the sounds of our surroundings. Like here, you can see the heat map, like red dot. So this is actually KB2 dormitory. So in KB2 dormitory, we have two roads on the sides of the dormitory, and we have too much noises on both sides of it. So what can we do is we capture the sounds of our surroundings. Then we actually get the longitude and latitude values from our GPS, like from our mobile phone GPS, and the time span of our recordings. Then we package the data into we have created sorry, we have not created, but we have used spatiotemporal averaging for heat maps. We also can use a Kalman filter, like 1D or 2D Kalman filter in this model, but we didn't propose it in our paper. We just used spatiotemporal averaging for heat maps. Then we package the data. Then we store the data in cloud storage like Google Firebase. Because Google Firebase is free, so like it's useful for people like us who are just starting to develop. Then then we use the machine learning classification of it. Like we can get data set from Kaggle. Then we compare the data, like what kind of sound we are getting. Is it construction sound? Is it traffic sound? Is it motorbike sound, etc.? Then we classify the noise type using ML classification. After that, we visualize that in the map. So the UI section, you can see it's not an actual mobile app, but heat map section here you can see it's actually done. But we have used like what kind of data? Like we have used a mock data. Like I know that KB2 dormitory has too much sound, so I have used a sound data. Then I created the model surrounding this area. Like here in this building and this building, two buildings get too much data. Also here in this section, we also have a kindergarten. So our maps can also be used because we have a kindergarten. We don't need too much noise in that area. So using this model, government officials can take measurements to avoid such traffic sounds or any kind of sounds. like they can divert motorbikes, or they can minimize the movement of cars in those regions.
So that's all. And about we can have also consider about yes, we have some kinds of limitations as well, because according to mobile hardware or design, we it may differ, but it's not that much. But about future considerations, we consider something like, if it's just too much like sensitive areas, maybe school, kindergarten, or hospital, they can give some push notifications to people that it's like this. So yeah, these kinds of things are in our future collaboration. And yeah, that's how like we work in SDG 11, where we are committed to create a sustainable, safe, and inclusive cities for all. Thank you. If you have any question, you can ask.
Thank you, Rahim and Nafis. Very good. The title is very exciting, actually, very real. It shows a real problem in the urban area, especially in Almaty. I see this is a big issue that we have a lot of traffic here, and most of the traffic is, I mean, has much noise. Actually, I had been living in some area near the main road last year. So I left that home because of this issue.
Yes.
Okay. So this topic is very, very good, very nice. So I think you can continue working with this. Nafis, you can talk with me. Okay. So we will, because if you collect the real data from different spots in Almaty, and we propose some good analysis and good results, so it can be produced a good publication and good results in future. But
Yes.
topic is exciting. So how, I mean, so let me ask the question. So which machine learning algorithm you use for the sound classification?
Can you just repeat your question again?
So what machine learning algorithm you use for the sound classification, noise classification?
So second, I use
So
this one. Okay.
Did you do
we,
the noise classification?
yeah, we understand. So
In machine learning classification.
so basically, we used a logistic growth model, but it's not in the it's not in our poster, but it's in the paper.
Abstract paper, actually. Okay, wait. না জিজ্ঞেস করতে কোন মেশিন লার্নিং মডেল ইউজ করছে
Machine learning model. Machine learning model, we have used this MFCC from Audio Softmax.
Okay. So okay. So what? How many noise? I mean, how many classes? I mean, what type of the noise? One is the traffic, maybe. One is the, you say, the construction.
Like the classes actually depends how many classes, but we are for lightweight use, we are just limiting our classes into 2 or 3 sections. One is traffic data, one is one is construction data, and other kind of data like the sound from people. Like when you have too much concert in some areas, then you have sounds from people. So we are just limiting to three classes because of lightweight use. So we cannot just burn a mobile for a machine learning model. Yeah.
Okay, good. Okay, thank you very much. I have no more questions.
Yeah, okay. Thank you so much.
Thank you so much, sir.
Thank you very much. So the next presenter from here in my. So all files here.
Hello everyone, do you hear me?
Yes, we can hear you.
Okay. So again, hello everyone. My name is Marat Mirbulat, and the topic of my presentation today is the development of a digital twin for the solar water purification process. It's directly related to the SDG topic for the water and clean water and sanitation. So currently, oil and gas industry relies on the distillation, since to separate hydrocarbons based on their boiling points. This process directly includes the ACD components like hydrogen sulfate, here's the formula, and carbon dioxide, which are very harmful for the living organisms, environment, metal due to the corrosion, pipelines, and as well as the equipment industrial. And this technological process, digitalization, includes the collecting of this acidic water and its purification in order to be reused. So unconventional treatment systems are not equipped for real-time simulation or smart control. This work uses a digital twin, which is the Honeywell product of the soil water purification process to improve operational safety and reduce emissions. So what about the methods? Here, sorry, let me scroll. So here we use the digital twin to evaluate the model. The technological process was taken from the real industry in 2000 from the Kazakhstan main oil and gas organization factory. And here is the R492 release from the Unisim Honeywell design. Because as you know, the currently QB2 has its laboratory. That's why we have this software. Also, it contains 3 main core units. Here is a 3-phase separator, absorber column, and the storage tank. Their datasheet information was also taken from the documentation from the technological process in order to validate and evaluate the results. And the main cause is that the system operates in both dynamic and static modes, which lets to understand its behavior under different conditions. Here, as an example, pressure control has been introduced due to the complexity of the work. And here we use split range control, which takes as an input 1 pressure and 2 valves, which first one is the fuel valve, the second gas, and second one is outlet valve gas. PV where PV001 and PV002 respectively. Here you can see from the figure how the pressure value control these 2 valves, which is the directly split range control approach. And second, Experian PKS, it's also Honeywell distributed control system, is applied to directly collect the results, their values, and also apply the control from the operator screen. The main contribution to this work is a fully dynamic real-time connected simulation platform that improves water treatment control precision and sustainability. About the parameters, collecting just mentioned all the parameters we use here, the 6 of them, 7, sorry. And we have control models to provide the real world distribution control. So according to the results, here you can see the figure of the model in dynamic mode. Here you can see, it's impossible to zoom more, but here you can see 1 pressure value, which inputs the PIC 100, which is then separated for 2 valves for our 3-phase separator. And the results are that the twin achieved that as a result for the purified water, it contains water as a 99.9 in period of percentage. And with trace amounts of nitrogen confirming high separation efficiency. So the system consists of maintain target pressure and level set points due to the PID regulator and ensuring operational stability. So here we provided the Twins is a robust platform with Experian PKS implementation. But due to the lack of the space, it was impossible to insert the screen from the Experian PKS. So what is the relation with SDG? As I mentioned before, the topic is clean water and sanitation. And here in oil and gas refineries, it takes a very significant place due to its environmental problems. And social impact, it has that improved purification, reduces toxic discharges, and protects nearby communities and ecosystems. By the way, from the Honeywell statistics, the digital twin lowers testing costs, enhances process safety, and improves plant efficiency by 80% or 8%, while capital expenses by 10%. And here that's all. You can ask your questions regarding to the work. By the way, about the further improvements, I'm currently working for the, not currently working, but already implemented, but still I have not included because due to the lack, the fuzzy control will be, is currently replacing this typical PID regulator control approach. That's why here non-expert users can even work with no even deep knowledge about the system to understand what happens and regulate it. Yeah, that's all. Please. If you have any questions, you can ask about. Which part? This? I can. Economic impact, you mean? Yes, here we go. Yeah, this statistics was taken from the official Honeywell website. And that's why, due to the lack of this, to the space, I couldn't insert it in the references. But I also included into my current work and also sent for the publishers into the article as an article. And it's been approved today, exactly, by the way. So it took the examination. Sorry, could you say a bit louder, or a bit maybe closer? When I compare it to
input output from investment studies. Sorry, we can't hear you.
Hold on. Okay. And due to the high expenses of the problems, since this one is mostly like, you know, eco-friendly approach, since it uses a standard approach to refine the oil, but due to the ACD components in the oil, they're extracted and they can be reused for the other like needs, for example, environmental, water, to water the plants, I don't know, and like doesn't matter for now. But even there are no pollutions in the area and etc. I think currently, or at least in Almaty, we know that people waste, I would say, even plenty of money to reduce the pollutions, while we try to decrease its amount in oil and gas area. That's why I think after maybe 2 or 3 years, this would be profitable more than expensive. Yeah, it's eliminated in the source since we don't throw it in the air. Finally, because this water could be reused again and not sent to the environment. Okay. Any other questions, dear colleagues, visitors? Yes, you know, currently I have another work. I just like use this work in the next, not example, but a research. It is called like fuzzy expert system, but for this technological process, but it doesn't matter for which one it could be applied because it depends on the knowledge from the experts. Since you know, as you know, here I use the knowledge from the documentation, which replaces the experts if it's because it's impossible to catch them during this engineering among the engineering stuff. And here we use just like fluently speaking, for example, if pressure high, then I need to decrease this one. That's all, like the whole logic. But due to the artificial intelligence and math approach, it lets me to, and due to the high amount of rules, of course, it lets me to apply it for whatever process I would like to do. But first, it is necessary to research it. Since it's impossible to create the control without any knowledge, of course. And it would be even much cheaper because there is no need to spend lots of time to create the software program too. Because, you know, plenty of engineers, they don't even use deep theory knowledge, for example, from the control, like what's the time, constant settling time, overshoot, undershoot would be needed to achieve the set point. But here we use just like a human-based talking approach instead of deep math. Yes. Yes. Yes, because it handles uncertainties and the cases where it's impossible to understand what to do in specific situations. For example, I don't know, there is some lagging, but here the software doesn't implement, for example, how to handle it. While the fuzzy logic, it provides a smooth like solution to how to like avoid it or handle it. It doesn't matter. I did like here is it's published in an article. The second current work is going to be, I think, this week maybe sent to the Scopus article as well, and also the like how it's called, forgot even in Russian. No, AVM, авторское свидетельство еще. What? Authority, yeah, like after authority. Thank you too for the question. Okay, any other questions? Okay, thank you very much.
Good afternoon, everyone. Yeah, I guess we don't have much time, so I'll try to be fast enough, but yet specific enough. So here I am to present our poster for our article, Intelligent Multi-Agent System for Secure FinTech Using QML. So we as a team present a hybrid intelligent security framework for fintech environments that integrate quantum machine learning and reinforcement learning agents that detect and respond to cyber attacks in real time. So the system continuously monitors network traffic and applies a rational quantum classifier to detect the threats. Once classified, a corresponding RL agent determines the best mitigation strategy. Each event is logged on a private Ethereum blockchain via IPFS to ensure traceability, auditability, and temper resistance. So the aim is to improve cyber resilience for finance-related digital systems such as smart contracts and IoT-enabled financial infrastructures. This approach addresses challenges related to zero-day attacks, interpretability, and distributed trust. So for our methodology, we've developed the sequence of actions. Oh, sorry, let me just put on a slideshow and scale this enough. So the system consists of three main parts: the defense agent, QML agent, and RL agent. And a blockchain logger that logs every event that is happening. If you'll be very interested in our system, you can look through the whole diagram, through the whole system of our architecture. But as I told you before, defense agent sends the traffic data to QML agent. QML agent classifies the threat. It sends it back to environment. RL agent selects an optimal defense strategy, and the defense sends it back to defense agent to use this strategy. Every action, as I told you before, is stored on chain via IPFS CID and hashing system. Here is the pseudocode for the main loop. It basically says what I've just told you. And so we've simulated the experiments after training of the agents. We've simulated the experiment on Ganache security system using 1 to 15 blockchain nodes. Basically, there is a trade-off between the number of nodes and the whole efficiency of the system. The more the nodes, the less the efficiency, but it still provides a pretty solid latency and gas usage. Yeah, so classification results of our QML agent is good enough even with simulated noise. The average, here you can see the reinforcement learning agent reward graph. And basically these results demonstrate that logging real-time cyber defense actions to the blockchain using QML and RL-based agents is practical enough. The proposed system enhances integrity and transparency in fintech environments while reducing the need for manual oversight. But of course, we've identified the challenges for our work, and basically it is increased storage and gas costs with scale when in real life there will be more than 15 nodes, and it basically means that the system will work slower and slower. There is a risk of misclassification due to the overlapping features, and interpretability limitations in reinforcement learning is a challenge too. Our work mainly relates to SDG 9, the industry innovation and infrastructure, and also slightly covers the SDG 16 for justice and strong institutions by ensuring integrity, auditability, and resilience of digital financial system. So yes, this approach offers scalable applicability and regions lacking robust financial cybersecurity defenses. We didn't have enough space to put all the references in it, but this paper is sent to a scientific journal. So when it will be published, you can contact us and we will send you the work itself. Thank you for your attention. I'm open to any questions. Yes. Yes, it basically the whole like idea behind the blockchain and behind the blockchain integration. When we'll be connecting IoT to our like framework, it is really useful to have the on-chain logging in it. Like fintech, basically now it has a trend on involving the IoT in there. So yeah, our work is connected with IoT. Yeah. Mm-hmm. Mm-hmm. Well, it is not the IoT blockchain connection. The main idea behind it is not the direct monetization, but the monetization lies in decreasing costs due to blockchain cybersecurity. Like it provides more security to all operations. Like for example, in banking systems, if we will be using blockchain transactions, for example, when we like just cash in using cash in or ATM machines, these operations will not be traceable for example, hackers. And if we with this model we decrease the number of hacking machinations, or just like these cases or when people just steal money from people and banks, it will be the monetization behind it. Like it is just the most simple thing is security. Yeah. Sorry? Maybe not now, because it requires a lot of computational power to really integrate it into real life scenarios. But maybe in the future, yes. Thank you.
So the next presenter is Aray. So could you please share your presentation?
Hello, everyone. Can you see my screen?
Yes.
It's my poster opened, yes?
Yes, yes.
Yes. My name is Arana, and I'm the second degree master student at data science. Today I would like to talk about mental health. It's SDG number 3 about general well-being. Yes. And now we all know that AI and ChatGPT is used not only for job or for studying, but some people use artificial intelligence for as psychologists. So we know that AI tools now increasing in psychology. So the thing I want to say that, as Yoshua Benja reminds us, if we want machines to think, we must first teach them to understand us. So in the case of mental health, it's important to give insights to machine to understand, to better understand how the brain of people work. So the best method, not best, but a more accurate method for designing how brain works is ESG. It's electro signal, using electro signals to understand the brain. But we know that it's it can be expensive, and it can be it can work only on a small amount of people. So my work is based on survey data, because we have the main purpose of my work is to work on a viable open data source, which is World Values Survey. It contains over 150,000 responders, and the participants were across the whole world. And the research questions are, Анастасия, по-моему, в ту часть отца. Да, да. Извините, пожалуйста. And well-being, what is well-being is not only about a good mood and just happiness. It's about our financial state, about our health general, and mental health, and so on. And we got psychological constructs like sense of agency and self-control. The agency means it's like being the person who knows that you are the initiator of your actions, and the output from your actions is a cause of your actions. And the self-control, it's like controlling yourself, controlling your impulses, and so on. And we try to explain well-being by agency and self-control. And we set hypothesis for our study. So it's how do agency and self-control affect well-being? Does self-control mediate the agency well-being link? And the Bayesian model help simulate psychological updating. We have used the Bayesian inference to explain the relationship between sense of agency, self-control, and well-being. Here you can see that what we did, we take the survey questions, and we got there only the questions and the answers. The answers were different. Somewhere it was binary answers like yes or no. Somewhere it was like rating your answer from 0 to 10. And we did the variable mapping. There were questions about, for example, about politics, and from literature that we read, we know that if a person is interested in politics and takes somehow some actions in political questions, then the person has a high agency. So if person has a high agency, we set score 1 for this person. Having agency 1. And like this for many questions, for self-control, well-being, agency as well. And then we try to do some hypothesis testing, as I've said, and then mediation models, and explain it, try to build a model with Bayesian inference that can predict well-being based on agency and self-control. And as a result, we got positive results. And individuals with higher perceived agency reported significantly greater well-being, and the same with self-control. If person has higher self-control, then the well-being is high as well. Also, self-control, here you can see in the graph, self-control also moderates the relation between sense of agency and well-being. Here, blue line stands for agency, and orange is agency plus self-control. It makes our model more, it affects our model, as you can see. So, I think that's all. Thank you for your attention. If you have questions, would be happy to answer.
Okay, hi Arina. Thank you for your presentation.
Thank
Yes,
you.
so any questions from the floor? No questions about agency and well-being. Okay, so I will ask then the question. So what would be the main output of your work? So what does it mean for SDG? So how would you communicate that, like maybe in one sentence? So yeah.
In one sentence? It would be hard to say it in one sentence. Generally, it's about well-being. It's SDG topic number 3. And the mental health is taking care about mental health is the main affecting stuff on general well-being, just caring about your mental health.
Okay, so would you say that agency is the most important factor that affects mental well-being?
No, I cannot say it because you can see in this graph that agency has correlation with positive correlation with well-being, but it's not like this. It's like not one-to-one relation between well-being and agency, because well-being is very big psychological construct, and it contains it's affected by not only by agency and self-control, it's affected by many factors. So I cannot say that the agency is the main main thing that defines well-being.
Awesome. Okay. Thank you very much.
Thank you.
Thank you. And next speaker, I believe here, Agirim Abdullah.
Hi everyone. Can you hear and see me?
Yes, we can.
Just a minute. I will present my presentation. Can you see my presentation?
Yes, perfectly well.
Okay. My name is Abdullah Agirim, and my topic is anthropomorphism of AI nudging in management of financial systems. And I'm second year master student of Kazakh British Technical University. What about my research? As AI becomes very popular and integrated to mobile banking systems, it's very important to understand how human-like features affect the users, how they interact with these AI tools and AI features, so that our research focuses on anthropomorphic traits such as emotional tone, naming, or like a voice, visual appearance, and how this impacts user trust, comfort, and engagement. So I I have 3 questions. To do this research, we have 3 questions. They are: which anthropomorphic features enhance user trust? Can naming or emotional tone increase perceived human likeness? And how does visual design influence comfort and communication? About methods, we have mixed method research. First is qualitative and second is quantitative. To have the quality for search, I conducted with several, especially with 7 data scientists of several banks of Kazakhstan, with using LinkedIn, and have an interview with them. After that, we did a hypothesis, as you can see in this feature 2, second feature. It's human likeness of AI, naming of assistant, emotional expression of AI, frequency of AI use, visual appearance, preferred tone, and human likeness of AI. Then we make a survey for mobile banking users, especially if I say with quantitative data. It's 18 question online survey and collected over 180 users with aged 18 to 35. Then we use chi-square, Kruskal Wales, and Spearman tests to know interpretation of this hypothesis. So you can see here test statistic and p-value. As you can see, the hypothesis 3 and 4 significant. Hypothesis 5 is also significant, and others non-significant because of their value. After that, we tried to match them, our quantitative and qualitative research. Here you can see the answers of our data scientists, how they reacted to our hypothesis. And the most valuable thing in our research is segmentation. We made user segmentation based on AI attitudes. Here you can see the 3 clusters: AI skeptics, AI enthusiasts, and pragmatic users. After that, here is the results of our research. Here is a note: interview insights demonstrate partially support for the hypothesis, while emotional expression, repeated exposure, and visual appearance were consistently emphasized with hypothesis 3, 4, 2, 5. And other factors such as naming or tone, it's a second hypothesis, and 6 were viewed as context dependent. Here are our calculation. And the cluster name increased information but not trust. Second is informal tone, and third is cluster analysis. I want to thank my supervisor, Alina Gutoreva, for helping me a lot, and KBTU Research Support Office, because we tried to conduct several banks with KBTU, but it's not so successful. About limitation, we have a limitation because of data. I have only 118 users who gave me feedback, and who have a survey. So that we think if data will be more, then research will be more successful. And here's the references. That's all. If you have questions, I'm ready.
Yeah, big applause. You go.
Okay. So thank you very much. Right?
It's a Girim.
Oh, sorry, Girim. Actually, I couldn't listen to the whole presentation, but I really like the presentation because I saw the poster. It was very interesting. And do you have any questions from the hall? No? No? Okay, so we can move to the next slide.
Oh, yeah, okay.
Yeah, thank you very much. So we can move to the next presenter. Alan? Oh, yes, okay, Alan.
Yeah, I'm here. Could you please confirm if you can hear me well?
Yes, yes.
Yeah, and if my poster is also visible on the screen.
Yes, it's all good. Alan, off you go.
All right. So, hi, my name is Alan Mirimbaev, and I'm from KBTU. And this project is titled Evaluating ChatGPT as a Virtual Medical Assistant, Prompt-Based Design and Expert Assessment. It explores how a large language model, specifically ChatGPT, can be used to assist general practitioners and other medical specialists in low-risk supportive roles like symptom triage and health information. So, as the demand on primary healthcare givers grows, and physicians are under pressure to handle more patients while maintaining quality. And at the same time, more than 30% or so of adults are rely on internet for system checking, and however, online tools are often unreliable and unsafe. And this led us to explore whether something attainable, something that's really close to the end user, something like ChatGPT, can be used when properly instructed through prompt engineering, could act as a safe, structured, and helpful assistant in a medical context. So in our focus was on to develop a prompt, design a layer system prompt that shapes ChatGPT's behavior to act like a virtual medical assistant, and then the study aimed to attain medical professionals' evaluation of the performance in realistic consultation scenarios. So at the end, the study aimed to develop a prompt aligning ChatGPT, deploy it in a real-world interaction with physicians, assess its behavior across 12 clinical communication and safety dimensions, identify limitations in emotional responsiveness and proactive questioning, and inform future improvements in AI design for healthcare support roles. So we designed a 5-part prompt inspired by medical communications guidelines and triage protocols. It consisted of framing the identity, establishing the assistant's role as a virtual medical assistant, behavioral tone, emphasizing empathy, non-judgment, and clarity, symptom inquiry, structured questioning, safety disclaimers to actively ensure that ChatGPT does not provide diagnosis and always recommends real consultations with real-life professionals, and supporting tools such as directing users to CDC, WHO, or local healthcare services for proper consultation. So we had 10 licensed physicians, including general practitioners, pediatricians, infectious disease specialists, who used the model during a 1-week testing phase with representative scenarios. And at the end of the week-long trial, they evaluated the prompt ChatGPT with the special prompt using a 12-item questionnaire organized into 4 key domains. First being symptom gathering skills, information accuracy, empathic tone, appropriateness of advice. And each item was rated on 5-point Likert scale, and open-ended feedback was also collected from the physicians. So as you can see on the table 1 here, it demonstrates the sample questions from the for each of the evaluation domains. The medical assistant ChatGPT received high scores in clinical safety and professionalism. So it emphasizes the importance of consulting a real doctor. It prioritizes patient safety and well-being, and avoids being judgmental or giving dismissive responses. These results confirm that the structured prompt successfully constrained ChatGPT within a responsible behavioral envelope. However, the limitations also were noted in the moderate scores, which showed that such cases as empathy and compassion's tone was respectful but lacked emotional depth, and also initiative and questions was scored the lowest, showing that the assistant waited for input rather than probing further to acquire additional information from the user. So doctor emphasizes that while the assistant was predictable and safe, it lacked adaptive dialogue and genuine warmth, something that we would much rather do with humans, which is a critical part of real-time consultations. So prompt engineering can effectively align ChatGPT with clinical expectations for triage like Laurel's. So the assistants can be used and be best suited for something like pre-consultation intake, health education, or structured symptom narration. And it's in no case it should be used as independent decision-making tool. So future improvements could also be focused on and should explore something like dynamic prompt chanting, conversational memory, and emotional fine-tuning on real-world de-identified dialogues. And human oversight is also is essential in directing whether the assistant should communicate with the end user, being the patients. And so we propose a human-in-the-loop model where ChatGPT serves as a support system, not as a replacement for a real-life expert or medical professional. So this project aligns with SDG 3, which being good health and well-being, improving patients across the access to safe digital health tools, and SDG 9, innovation and infrastructure by developing the scalable and ethical AI system for clinical context. Thank you very much for your time. I'll be happy to answer any questions.
Okay, thank you. Any questions?
Yes, thank you. I have
Yes,
a question.
please. Sure.
Thank you very much. Thank you for your presentation. So, can you? What is your contribution to this work?
So I was the one who worked on developing the special prompt that is designed to fine-tune ChatGPT as the virtual assistant with the traits that are commonly found in medical professionals.
Like in method and procedure, you say that. Can you go down, please, on your poster? Go down. Yeah, you said that the licensed physicians across multiple disciplines interact with ChatGPT using a carefully engineering prompt using. Yeah, so you ask about the reference number 6, right? So what is what is your data and how do you analyze it?
You mean the data acquired from the experts, or?
Did you generate your own data? Or you generate from open set data, or how do you get the data to analyze?
So no, we didn't get how to say we don't have data as numbers. So we had a qualitative triage, usability study, not a statistical trial, and the aim was expert-centered evaluation. Yeah, and
So
we.
this figure number 2, right? You show some graph here.
Yeah, that's.
Can you make it bigger?
Sure.
Okay. So how you get this graph?
Yeah, so we had 12 questions across 4 domains, which were answered by real experts, human doctors, and they rated the fine-tuned ChatGPT with the prompt after 1 week's usage with while consulting patients or afterwards.
So how you get this generate this data? Where you get this data?
From a questionnaire.
I mean, if you make question yourself, so you are not a doctor, right? So it means that the questions can be made only by a doctor who know the what question should be asked, right?
Oh, the questions were developed based on data that proposed how a general practitioner should a well-established general practitioner, or which could be helpful to patients, would act in a patient-doctor scenario.
So I mean, this is the very specialized area, right? So the question you put to ChatGPT, it should be the question only can be put by expert, and then
doctors use the model.
Then answer of ChatGPT, it can be understood by expert only, not like me and you, right? So then how you analyze it?
It's not basically, so the numbers that you see on the screen are put down by doctors analyzing the information that ChatGPT provided to them.
So
but initially the model.
So this is my first question. Then what is your contribution? You I guess that you study some paper, you put all the information on this poster, right? So my question is that what is your work? If you
that's all my work.
Oh,
yeah, so,
okay. Can I just maybe intervene?
Yes.
So Ilyas, is your question, so what is actually like the impact? So it was an experiment. So Alan did a international study. He went to doctors and provided the prompt to practitioners, and they used it in their daily work. And then they provided essentially the overview of how this prompt worked for them or not. So yes, there is, and we developed essentially, so in the beginning there is how to use ChatGPT and so forth. But of course, the better you there is no tuning, nothing. It's simple to use for practitioners, for doctors that are, not familiar with AI, but they start to use ChatGPT, and we show that it does help for in diagnosis. So it just simplifies the process, speeds it up, and follows up with the essentially the
okay. Professor, my question was very basic there about the data, right? So my first question was that how you get this data. So if he, as you mentioned, that if he went to the doctors and he put some prompts to them, and then they ask a question and get the reply, then it's okay. Then he can generate some data from the real experts. But if you do like himself, like he put some prompt on the ChatGPT, but
Oh, got it. So you needed, Alan, just you needed, so it's a feedback you needed to write, I believe, the examples of the prompt, right? That's
yes,
was
yes, right.
okay, got it. Okay, so just example, maybe a snippet from the actual script, well, the prompt, not script, the prompt for ChatGPT. Maybe not the whole thing because there's quite a bit of text, but yeah,
Right.
just for the future. Awesome. Thank you so much.
Okay.
We should move on to next speaker. So let that be now Jandos here, Abdurshif.
Hello, everyone.
Awesome.
Can you hear me?
Yes.
I have a request. I'm not connecting from my personal laptop, so I don't have access to my poster. Can you please share the screen with my poster if it is possible?
Okay.
Thank you very much.
So, Jandos, your, okay, I see. I see.
Mhm.
Okay, can you see the screen?
Yes, thank you very much.
Mhm.
So hello everyone, my name is Jandos. I'm second year master's degree student in data science, and my topic is cognitive and personality driven patterns in music frequency preferences. So, so the music industry, recommendation industry is developed from the 2000s, and these recommendation systems are highly used in the music. There are two different music recommendation systems, which are um, which are connected only to the uh, technological part of like coding part to recommend the system, but there are lack of emotional or personality impact to recommend some music. So in this poster, I would like to contribute how personality and emotions can affect to recommendation system. So my research question is, can personality traits and the mood predict music frequency preferences, and can these insights be used to build more emotionally intelligent recommendation system? So my methodology is to collect high quality data through the Telegram bot. So I've used Render and the Google APIs and the Telegram bot service to create a questionnaire fully anonymously to connect the data. And my questionnaire contains from 4 different sections, which are demographical part, musical ranking part, big five questionnaire, and the music in mood. Here you can see my methodology scheme, and as a result, we have collected about 1,600 answers from different persons, and we've created clusterization to understand how um, how personality can be affected to recommendation systems. So overall, there are 3 clusters. First cluster shows the high openness and the high extroversion of people. They prefer high frequency music like classical and energetic pop. In second cluster, there are mid-range frequencies and the emotional balanced tracks, which means that they tend to listen not only instrumental but also music with lyrics. And the third cluster is shows preferences for low frequency tracks such as EDM or lo-fi songs. Also, we found emotional state like listening to regulate the mood, or that music can be highly affected to mood. And this plays a more significant role in the music choice than personality alone, which means that not only personality can be affected, but if you will include the mood, then it will be highly affected to recommendation system. And here you can see our PCA visualization, which shows that 3 clusters are very different from each other. And if we will talk about SDG contribution, then it is the third. My research is the third part of the SDG contribution, which are well-being. Like why? Because as I said before, my questionnaire contains big five personality tests, and not only this, and also mood regulation and music. So I would like to thank my supervisor, Professor Alina, to help who helped me to finish my research and gain such perfect and amazing results. If you have any questions, feel free to ask.
Okay, thank you very much. Maybe someone have a questions online or offline.
Personality and music preference. What would you like?
I think it's very interesting work, and when you thinking to apply practically, where it can be useful.
I think that we need to get not only 1,600, not only data from 1,600 people, but a lot to create a good personality system. So my contribution is not to create recommendation system, but recommend what else can be implemented in the recommendation systems. I think in near future I will do this job.
Okay.
How to improve the recommendation system.
Okay.
Yes.
Emotion and so forth.
I see. Okay. Thank you very much.
Thank you.
We are left. It's for me.
Yes. So the next. Thank you very much, Jandos. So we can move to the next presenter. It's what's her name? Mirwert.
Hello, yes, I'm here. I will now share it. Yeah, can you see my screen?
Yes.
Okay, yeah, so my name is Virer Tasmbaiba and I'm second year master student in software engineering, and my topic is, the thesis name is Machine Learning Approaches to Predicting University Students' Mental Health and Well-Being. So to introduce the topic, I would like to start with statistics about university students' mental health. So according to research by Pedrelli et al., a national survey of over 55,000 undergraduates, it identified anxiety as the most prevalent issue, mental health issue. And also, according to research, in Florida report, which was held in 2018, suicide rate of 20, it highlights suicide rate of 27.5 per 100,000 people. And this research aims to address, the main aim is to address the lack of research in mental health in Kazakhstan, and it also examines the use of machine learning. And the study collects responses to 7 validated tools. And our key objectives is gathering comprehensive data and analyzing, and also explore models. So here is the methods. So at first, we aim to collect it in all over the Kazakhstan, all the regions of Kazakhstan, and this is more like a preliminary work because it takes time to get the ethics commission and also conduct it all over the regions. So it's we first collect data from KBTU first year students, which was 200, more than 250 students, and they participated voluntarily and anonymously, and there was an informed consent. And here you can see my methodology figure. So first we collect the survey data, and also then we do data cleaning, and for now we just collect data from 250 students and did some data cleaning and analysis, and I will present you now results. Yeah, so the survey was conducted online and in collaboration with the University of Edinburgh and also with the support of UNICEF. And ethical approval was granted by both universities' committees, and the survey questions were validated by the clinical psychologist professors from the University of Edinburgh. And we also had demographic variables, demographic questions. And here you can see results and findings. So there should be more graphs, but that is I could put here. So we have here support level distribution and well-being level distribution. As I mentioned, we have 7 surveys, and to analyze first, I did some cleaning, pre-processing, so by removing some data. So at first I had 263 responses, then I had 233 responses by cleaning. So there were some empty responses. So yeah. So you can see here that by support level is mostly medium, not high. And also by analyzing well-being level distribution, we see that no person, no respondent reported high level of well-being, so mostly it's low. And so it showed medium levels of anxiety, stress and loneliness, and some experience high anxiety or depressive symptoms. And we also had correlation analysis, and it revealed that stress and anxiety are positively related, while social support negatively related to stress and loneliness levels. So to address this limitation, so it focused on only first-year students, and it limits generalizability. So as I mentioned, it's more like foundational preliminary research, and it will continue to cover all the universities, all the years of study. And it also captures data at the single point in time, while in future it's expected to do a follow-up survey. And so we need to continue the study. And in relation to the SDG, so it contributes to the SDG 3, good health and well-being. This work supports the detection and early intervention for mental health challenges among university learners. And we have social impact and economic impact. So social impact, it means by understanding this problem, this is particularly valuable because students face mostly challenges while they move on to a new university, new social life, new people. And this is a time when students mostly experience problems, and understanding this problem will help to enhance this mental health care and also improve quality of life of young people. And economic impact. I don't remember the exact research, but according to research, yeah, when we and I think it's also logically understandable, but because when we have early interventions, the costs will get decrease, and it prevents severe disorders, and also we can understand what age or what kind of population is most vulnerable to mental health. And yeah, so it will it can link to higher academic performance and less intensive treatments and less costs. Yeah, so as acknowledgements, so first of all, I would like thank my supervisor Alina Kudreva for her support and help, and also thank Professor Matthias Vanower and Rowena Pierce from University of Edinburgh, and also Aygul Kadirova and UNICEF Kazakhstan for their support. So here reference, I put only references for this research I had in introduction. Yeah, I have more references in this thesis. Yeah, that's the end. Thank you very much.
Okay, thank you very much. So dear students, colleagues, do you have any questions? You can ask from here.
So my question is, if we want to implement this in real life, how are we going to get this data, like from students or from some third party?
To get this data, so the results of the research surveys?
No.
You mean?
No, not results. The data sets, like if someone is having mental breakdown. So suppose KBTU has suppose one subject students has 30 students who are having mental breakdown. So how are we going to get information out of them?
I didn't quite understand the question, to be honest.
How do you prepare the data sets for this?
Prepare the data set?
Yes.
Yes. How did you prepare data set?
No,
And
if I want to prepare data sets, how do I prepare it? Like,
okay. If someone wants to create a data set, how the person can create this data set?
Well, we are creating data set by just collecting data from people.
By questionnaire, right? Interview.
Yes, with questionnaires, yes.
Okay. Thank you. Okay, thank you very much. So let's move quickly to the other participants. I think that we have only 2 participants left, right? Adina and Miras, right? Or okay, so maybe Adina, you can present quickly, and then Miras.
Okay, 1 minute. Can you hear me? Can you see my screen?
Yes.
So, hello everyone, my name is Adina Mirbaeva. I'm presenting my research about intelligent systems for the selection of information security systems. So, as we all know, cyber attacks are becoming more frequent and more complex, and traditional methods for selecting information security systems are mostly manual, not adaptive, and often rely too heavily on human expertise. And also, this makes them slow to respond to emerging threats. And the goal of my research is to develop an intelligent system that helps automatically choose an appropriate security measures based on machine learning for attack detection and fuzzy logic. For this research, I used for now, I use the CI/CIDS 2017 dataset, which has many grateful and different options to use for this research. And the next move on into the methodology, the system architecture. The proposed solution of my research is making the hybrid intelligent decision support system that is designed to help select appropriate information security system based on attack detection and impact estimation. And also it mainly consists of four stages. First one is the data pre-processing. Next is a machine learning classification, then fuzzy logic interference system, and recommendation engine. The first is the data pre-processing. I used the CICIDS 2017 dataset, which is publicly available and is widely used as a benchmark for intrusion detection for this kind of researches. It has many kind of features such as flow duration, pocket size, the byte count, and etc. The next one is a machine learning classification, the machine learning models. For this stage, it identifies whether a connection is benign or malicious. And if it's malicious, which kind of the specific attack type it consists. And also for this machine learning algorithm, there were used two main libraries. First one is a random forest, and then the next one is a logistic regression. The next one is a fuzzy logic interference system. Why fuzzy logic? Because it mainly mimics the human reasoning. Once the attack type is detected, the system uses fuzzy logic to estimate the potential damage of the attack. It also allows inputs that are imprecise or uncertain, which is ideal for cybersecurity, where exact thresholds are often unclear. And also the inputs to fuzzy systems such as flow duration, attack type, and etc. For example, for fuzzy rules, I used on my research, but I didn't add it. It's, for example, if the pocket rate is high and flow duration is long, then damage is high. Or, for example, if bytes are low and the flow is short, then the damage is low. And the last one is a recommendation engine. It's based on the attack type and fuzzy damage score. The system then suggests appropriate response actions and helps prioritize threats in a multi-incident environment. For example, if an attack classified as the DOS attack with a damage score of 19, for example, it would trigger the high priority mitigations. Or, for example, if a port scan with a score of 25, it may be locked but not acted on immediately, for example. So the next one is results. I developed and tested the hybrid system combining machine learning and fuzzy logic, as I mentioned before. And I want to explain these three main figures. The first one is random forest attack classified performance. The first one, to get for now the results of the research, I first used only ML, machine learning, then fuzzy logic, and the comparison table. The first one, in the first table, we can see that the precision among all flows as attacks, the 97% of them were actual attacks. And the recall, the 99% of the all attacks were successfully detected. This also means that the model is very reliable in detecting threats with low false positive or false negative. And the classifier was particularly effective also on detecting high value attacks, such as DOS or DDoS. And the second table, where we only use the fuzzy damage attack, this histogram, we can see that the damage scores that benign attacks are higher than the attack ones. And also the benign traffic clustered near scores of 0 to 20, and there were less aggressive attacks such as port scan on the dataset that I used. And the last one is a comparison between the ML and the fuzzy logic systems, is that we can see that, let me, um, here, here you can see it more precisely. Here we can see that if we compare to machine learning and together with machine learning and fuzzy logic, the attack detection accuracy is similar. But the damage estimation, for example, in machine learning is not available, but in hybrid approach is provided. And the same we can see in interpretability. They were binary output, but in hybrid we can find a linguistic output and numeric. And the next one is a decision support. We can see that it also again shows the binary one, that's like benign, but in hybrid approach is risk prioritized and also graded with recommendations. The adaptability is also here the same. So my relation to SDG is that it mainly contributes to SDG 9, the industry innovation and infrastructure, and also SDG 16 as a piece, adjusted and strong part. It uses machine learning and fuzzy logic to improve decision making in protecting digital infrastructure. And yes, and I would like to also express my gratitude to Aselia Vjalova, to my supervisor, for her expertise and dedication in my research. So yeah, and here's the references, but there were a lot more, but for this poster, I used only these 5 main ones. So yes, if anyone has questions, you can ask about my research. Thanks for attention.
Okay, thank you very much. If anyone online and offline has a question, you can ask. No? Okay, thank you, Adina. No questions. Yes, so we can move to the last presenter, Miras. If you could please quickly be the final one.
Yeah. Hello everyone, my name is Miras Kadlaev. Do you see the screen and hear me well?
Yes.
So my topic is building damage assessment using aerial imagery after disasters. Let me start with introduction. So natural disasters such as earthquake, hurricanes, floods, and wildfires pose a significant threat to infrastructure, economic stability, and human lives. An accurate timely assessment of building damage in the aftermath of such events is crucial for effective disaster response. This research will focus on building damage assessment using AI and geospatial image analysis. Namely, the objective is to develop a deep learning-based model that can classify and identify damage and undamaged buildings. Approach is to detect a change over a period of time with a pair of pre- and post-disaster image. At the core of the approach is hybrid deep learning architecture that combines CNN with transformer model. Now, talking about the method, initially, pipeline of the model begins with CNN to extract detailed spatial features from each image. These CNN help capture structural details like building shapes, textures, and spatial patterns. The extracted feature map from both images is then reshaped and passed into a transformer model. And in the transformer model, the decoder processes pre-disaster image to build a contextual understanding of the scene before the event, while the decoder compares those features from the post-disaster image. And through self-attention and cross-attention mechanism, the transformer is able to focus on areas where some changes occurred and then classifies the damaged and undamaged building. This architecture allows the model to combine local sensitivity of CNN with transformed model and resulting in a more accurate and robust damage classification system. Now, briefly about the pipeline overview. We have input layer. We have two pair of data in pre-disaster image and post-disaster. Then we have pre-processing layer where we'll do image normalization and data augmentation. There's feature extraction layer using CNN, where CNN layers extract detailed spatial features from both images, and the output will be high-level feature map from both pre- and post-disaster images. Then I'll do feature fusion, where I concatenate features and combine pre- and post images to create fused feature tensor. Then mainly there's a change detection with transformer model. Transform encoder process the fused features, and self-attention mechanism identifies long-range dependencies and key changes in the scene. After the transformer model, I'll have generated a change map. The model output, each change detection map highlights a thin area of significant change. Finally, a binary map will be the final output, where will be indicated damaged and non-damaged area. At this stage of the research, while final results are still being developed, several key insights have emerged from early stages of model design and experiment. Initial observation confirms that using hybrid architecture, combining CNN and transformer model shows promising results. Now, several CNN models are used, including UNet, ResNet, and ResNet v2 for feature extraction. Here's a table containing various CNN models with the purpose of building detection. In the second column, there is a data set, and the third column indicates accuracy of how many buildings were detected. This is existing literature, however, I recreated it for CNN and for feature map. Now, relating to SDG, this research supports sustainable development by enabling faster and more accurate assessment of building damage after disasters, contributing directly to SDG 11, sustainable cities and communities. By using satellite imagery and deep learning, the model helps disaster response team quickly identify affected areas, prioritize aids, plan recovery more effectively. It can be implemented by governments and emergency services as part of national disaster management system. The social and economic benefits are significant. Quicker assessment leads to faster response time, better use of resources, and reduced loss of life and property. Ultimately, this work enhances community resilience and supports safer and more sustainable urban development. Thank you for your time. If you have any questions.
Okay, thank you very much, Miras. Dear colleagues and students, do you have any questions, online, offline? What is your implementation, right? Okay, so Miras, what is your implementation? The question from the call.
So as I said, the work is still in progress. The idea is to use hybrid model where I have CNN as backbone and transform model to specify the change over time. What is implemented for now is CNN backbone, where I have building detection models used and use their feature map.
Mm-hmm.
That answers your question.
Yes. Okay. Okay, thank you very much. So today we want to thank all participants who are online and offline and who presented today. We hope to publish the book chapter with ISBN by Friday and send the electronic copy to all of you, and also certificates of attendance and presenting your work will be sent to your email scans, and the original certificates will also be printed by Friday. Also today with our commission, we discussed, we decided like by exprompt, right, to give like three like small presents to 3 works, and one present goes to Alina's student, which is related to mind, right? Arai, yes. And present to Alina, and this will be given to Arai. Thank you very much. The second also was chosen by professors, which is related to traffic noise, urban noise, right? It's thank you very much. And the last one goes to Timirbulat Maratova. The work is related to the water cleaning, right? Unfortunately, he left, but we will give to his supervisor, Timur Samigulian. But all students, of course, will get small presents, because if you would come offline, you would get the presents, and therefore, when you be in the university, we will share with you the notebooks, pens, and Macs. So whenever you are in the university, please approach me in room 428, and you will get presents from organizing committee. Thank you very much for your attendance. and see you next year, right? Thank you. And bye. Thank you very much.
Thank you. Goodbye.
Thank you.
Bye.